to the Know Before You Fly. Know before you fly your drone. And yes, we are recording this. So later on, if you want to look at it again or share it with somebody, usually it's about a week that it takes for us to upload it onto our website, the North Texas UAS.com. So again, this is our 20th. So we have a lot of the recordings of our past sessions. Just last month, we had the mapping and LiDAR. It was really, really fascinating. So again, the reason we do this North Texas, the UAS Safety and Integration Committee, that's part of the North Central Texas Council of Governments. This is one of the initiatives. More and more, we are seeing applications with uncrewed aerial systems, and we want to make sure that our airspace is safe and that the general public can see the good that this technology is providing. Speaking of that, I want to introduce you right away to the Director of NASA Aeronautics Research Institute, Dr. PK. PK, are you there?
Yes, I am.
Hi, well, welcome. Will you tell us a little bit about the background, how you got involved with NASA, and what's your main objective with your position there as the director?
Yeah, thank you. So this is almost 30 years ago. I was working on my PhD dissertation. I got interested in the topic of air traffic management after listening to a conference like this in Cincinnati. And I've looked for opportunities in that domain. And while I was doing dissertation, I found a job that will allow me to work half-time on air traffic management related work, which was really fascinating at the time and still fascinates me today. So I started working with FAA contractor and then finished my PhD, and they gave me a full-time job. And after 10 years, so this was 2001, after we became US citizen, FAA hired me and they sent me to NASA for 2 years. And then after 2 years, I switched to NASA. So that was 2004. But ever since 2002, I've been located at NASA Ames. And the first 10 years of my life, I spent at FAA Technical Center. It was fascinating learning. And then I came to NASA Ames. And since then, I've been working on improving capacity, reducing delays, increasing efficiency of airspace operations. And then almost last 10 years, I've focused on drones, and now drones and eVTOLs and a few other things. So that's sort of my background. And in my current role,
30 years that you've been doing this,
get excited about.
Go ahead. I was just going to say, with 30 years, you had the front row seat on what the where this technology is going, because in the beginning it was only used in, like the DoD, Department of Defense, and now it can be used every day by everyday citizens. So that's really
absolutely, yeah. It's great to see the consumer applications and enterprise applications beyond just the defense applications, and that's why we started to worry about how do we scale these operations in the airspace without overloading the air traffic control system. So that was when 2013-ish, I started to work on this topic on manned aircraft system traffic management. And now that construct has been adopted by KO and many other countries, including FAA. So we're very happy to see the possibilities. There are things that need to happen so that we can continue to make progress and stay competitive. And in my talk, I will definitely share those as well.
The reason I asked you to join us today is because I was at the Chata Aeronautics conference a couple months ago, and you really impressed me with the foresight of forecasting what is going to be our biggest challenges. So I would love to hear a little bit more and elaborate on that.
Yeah, so great, thank you. So I would like to talk to you all, share my views about opportunities, but the challenges that exist today, which can be turned into opportunities. And I preferred not to have slides this is my no slide Saturday. We have a lot of slides on the weekdays, so I said I'd rather do this a really good conversational interactive session. So by any means, ask questions along the way. All the audience members, thank you for those who joined on Saturday and listened to us. But definitely ask questions as we go along. So my personal view is uh, any industry, aviation industry, to flourish and be a really solve problems for our community and society, we need to be able to scale it. So if the drones operations can scale, they can support deliveries, infrastructure surveillance, agriculture, and many, many, many use cases. Same thing with electric vertical takeoff and landing. If we can get them to every location, every zip code almost, I would like to say that aviation should touch every zip code in some way, shape, or form, then that can be really powerful in transforming our society. If you just look at the long-term vision, let's say if you are successful with drones and successful with electric vertical takeoff and landing type of vehicles, we don't all have to go through the same highways to go to the central business district to jobs. The businesses don't have to locate in the same place. People don't have to live by the highways, by exits of the highways, because they want access, easy access to transportation. You can spread out much more. Businesses can locate further away from each other. Houses can locate near basically areas where they really would like to stay. And you can have much more integrated living, green spaces and such. But right now, that's not how it works. It's all based on the transportation access. So that everybody is co-located, commingle in the places where you have easy transportation. And that causes transportation jams, right? So now we are trying to unleash those. So that's the true power of aviation. I think aviation can transform the society in long term if we can reach through third dimensions in many places through air. Then you don't all have to locate. We don't all have to locate at the same place, and that's really going to be very exciting future. There are so I'll just give you one example in DC area. There was one Marriott, I believe, that they had to relocate because the people who were working there could not have easy transportation access. They had to take metro, they had to take bus and walk. And if that's the kind of challenges we have. If we don't have transportation, then the businesses don't flourish. So they had to relocate closer to the metro stop. So people who work have access to that facility. So I think we are onto something really transformative with drones and electric vertical takeoff and landing, as well as in general electric vehicles, which will be quieter so they can go into the communities without making the kind of nuances that noise problems that we experience today. So that's the painting the future. That's the true power of the aviation that can actually help us transform society. The question is, how do we get there? And what are the barriers to that? And what can we do about it? So let's talk about each. So I'm going to talk about four barriers. One is the airspace barrier for scaling in the air. Second is to making sure that these vehicles are airworthy, certificated, and safe. And the third is manufacturing supply chain. And fourth is the workforce. And the reason I chose those workforce, for example, is every company that you want to see flourish, be successful, you go to their website and they're hiring right now. There's not one single company that's in this space, drone space, as eVTOL, that is not hiring, and they're having trouble trying to find the most qualified people. Sometimes they tend to steal each other, but that's not the right way to grow. If you want to grow, we want to organically get new workforce in it. So that's the reason I chose the workforces there. Again, I'll say airspace. We'll talk about the certification and airworthiness and such, and then supply chain and workforce. So let's start with airspace. What we discovered is that the current air traffic management system has basically a way you can characterize as management by permission or management by clearance. Air traffic controller has a radar display. sees all their traffic on that display, what that means is only that person has information about what's in the sky in that little piece of airspace called we call sectors. When that happens, any change the pilot has to make in the air, whether it's altitude or heading or speed, they have to take permission from air traffic controller to say, hey, can I go right? Because the pilot doesn't know if there is someone else on the right side. So the air traffic controller looks at the display and says, yeah, you can do that. There's no conflict. Or if there are conflict, they a priori watch for them and say, oh, these two aircraft are going to come together, and air traffic controller moves one or both of them. In order to basically scale these operations, we have to make sure that we don't overload the air traffic controllers workload. So right now, the air traffic controllers limits the capacity in number of aircraft they can handle in the sky at a time. If you look at the entire system, we have 50,000 operations. One operation is arrival and departure, and second operation so arrival or departure is one operation. That's 50,000, and then at a peak we have 7,000 aircraft roughly. And the drones, we are looking at it in millions. So we realize that using the current way of doing things will simply overload the air traffic controllers and air traffic control system. So we need a different paradigm. So instead of management by permission, we said, okay, let's change the paradigm to management by exception. So have air traffic control system still be regulators, still be the in charge of airspace, but they can say what not to do instead of what to do every step of the way. So you say, here are the things that are basically available for you to use. Here are the airspaces that are not available to use for a variety of reasons, national security, manned aviation, whatnot. Then the next step to that is to give the same information the air traffic controller sees to the operator. So you connect them through digitally, you create a cooperative share and care environment. So the way we build this unmanned aircraft system traffic management, which is below 400 feet, and only for small drones as a starting point, 55 pounds and below, is to say, let's create a digital environment. Let's share the information about what's happening in the sky with each other. So I know your trajectory, I know my trajectory, I'm sharing so that we don't conflict with each other. If you are likely to be using the same airspace, then we can take basically different routes as you start your own trajectory and plan your trajectory. So that's sort of the idea. So you create this cooperative digital intent sharing environment. Then you need to have standards to say, how do I share my intent? What kind of, basically, how often should I share it, and so on and so forth. And then we said, let's make sure that third-party services can offer this and go towards service-oriented architecture so that we can have communication, navigation, flight tracking, flight planning, 3D maps, weather information can be provided by third parties, which basically open a new cottage industry for drone support systems, what we call USS, Unmanned Aircraft System Service Suppliers, which is another really good thing about this unmanned aircraft system traffic management. We opened a whole new industry, not just the drones, but the support services. So that changes the paradigm to management by exception. So now we can actually share the same information, create share and care environment, and allows you to go scale this. Once we realized that this works, we actually did 4 feasibility, significant demonstrations work with FAA. FAA has 2 pilot studies. FAA now is working on UTM field test. So significant amount of work went into it at the national level as well as ICAO level, which is International Civil Aviation Organization, to harmonize across all countries this whole construct. And it still continues. So we feel pretty good about this concept. Now, that will allow us to scale this. There is a great opportunity for students, professors, and new entrepreneurs to say, well, how can I be part of that ecosystem to support these services? Something called USS. So FAA has already adopted this construct of USS and Unmanned Aircraft System Service Supplier through their program called LANC. LANC stands for Low Altitude Authorization and Notification Capability, LAANC. So you can be a land support or land service supplier. Basically, at the near airports, FAA has adopted this construct where you can be the third-party service supplier to real estate agent, to photographer, to agriculture operator, whoever. Now there will be some companies who will want to provide their own services, like Google, Amazon, perhaps. If you have a large fleet, you might want to do that yourself. But if you don't have a large fleet, you might take advantage of someone else offering the service, so you don't have to spend all the capital on creating the service infrastructure. So that's the elegance of this way of looking at it without overloading the air traffic control system that exists today, making sure that the FAA still is in charge and has operational as well as regulatory authority. You allow the ecosystem to flourish and scale. So the UTM, what it does is, so as you share your trajectories and you track them, you're able to see that you are where you said you are going to be, which is very critical for beyond visual line of sight. Visual line of sight, you can basically watch yourself, watch where your drone is and what someone else's drone is and stay away from each other. But once you start to go beyond visual line of sight, you had to do that electronically. And that's where the UTM really is essential component, for strategic deconfliction, making sure that everybody stays away from each other and they track themselves, and you have an environment where everybody shares information about each other. So that's sort of the airspace focused idea. And the challenge that we had about scaling, I think we're addressing that through this UTM type of construct and unmanned aircraft system service supply. So there is a huge opportunity for many students and professors to do research on the characterization of the service suppliers. What service, how can we make them efficient? How can we have multiple organizations provide services at the same time in a secure way, and on many, many other research issues. But at the same time, there's also entrepreneurs who can take advantage of being part of this ecosystem. So let's talk about
TJ, I
the
have a
second topic.
question in
Yeah,
regard to, with your experience and what you're seeing happen in this industry, what do you think the timeline is? I think a lot of people, you're talking about the things that are going to help support the UAS industry, but timeline, I mean, do you see this happening in 5, 10 years? I mean, what are you seeing, and what are the challenges and that might delay the progress?
yeah, great question. So I mean, it's hard to give precise date, obviously, but I can walk you through several steps that are needed to get to that. So answer your question directly, within 5 years for sure. But here are the steps that are needed. So FAA just completed Aviation Rulemaking Committee. The Rulemaking Committee provided recommendations for beyond visual line of sight. Now FAA is looking at all those regulations and then doing their own due diligence and figuring out how the rules will get implemented. So they have to set up something called national rulemaking process, so once that process sets up, they will come up with a draft rule. People will comment on it, and then it will go into once it gets accepted, it goes into effect. So that's sort of the traditional pathway to making these kind of rules. And FAA is, as far as I know, they're well on the target of creating this beyond visual line of sight set of rules. So that's the next step. So we expect that will happen, and based on the ARC report, Aviation Rule Making Committee report that was released very recently. So that beyond visual line of sight will open really significant amount of revenue opportunities and the businesses for drones. So, whether it's agriculture, infrastructure surveillance, electric power, inspection, drone deliveries, and many other things that require you to fly beyond line of sight. So that's the key next step that's we are likely to see. And as part of that ecosystem, there will be the pieces from the UTM, whether it's service supplier, whether it's strategic deconfliction, the third-party services, all that will come after the rule is established, the standards are set, so people can build their products around the standard. So that's sort of the next big step that is looming. And I applaud FIA for trying to make sure that the innovation continues while safety of the entire airspace is also uh, stable. So it's really important that we don't create any situations that will complicate things. So they had to run the airspace system and make sure that it's safe. At the same time, allow new entrants into the airspace. So that's the balance they had to strike. And so far through UTM demonstrations and field trials and pilot studies, and they also have other programs like Beyond and IPP, so that was completed. We are making progress. It's slow. For some people, it might sound and feel slow, and some others, it's very fast in terms of the aviation type of growth. So, but we recognize that we need to keep pushing all of us together, even industry and government, to try to make sure that the innovation has the right opportunities.
PK, I think general public, general perception is so important because, number one, you really hit on a nerve, safety. I mean, that's the first thing. And, if we have, unfortunately, a catastrophe, I mean, that will really stunt the growth of AAM and UAS. But the general perception, I would think about 5 years ago, people were still thinking that, drones were only used to spy on people and that were invading their privacy, and that they were afraid of what drones could do. And now I think there is starting to open up the idea that if we can show more and more positive things like public safety and how they can search and rescue, how they can find a lost child or something like that, those are the things that are really going to impact the perception of the general public and what we can do. And I think that will help. When beyond visual line of sight, remote ID, flying over people, when the FAA really started talking to the general public about what they foresee, what kind of services, and what they're going to allow and what they're going to restrict, I had the feeling that things were going to change in 5 years. And like you said, it's so important that we continue to go forward, but we always consider safety first. So I thought that was a really good perspective. Again, instead of 5 years, maybe we'll see more and more within the 10 years, especially the beyond visual line of sight. A lot of the drones nowadays, especially available on the market, they don't fly very long anyway. I mean, they fly for maybe 30, 45 minutes. But the more the technology moves into longer flight, that will provide the beyond visual line of sight. And that's why it's so important. First of all, we start with safety first, but then the technology will grow along with the rules and regulations. I mean, not saying that we want a bunch of rules and regulations, because the majority of the people that operate, that are pilots, their objective is safety first. Because if they own a company and they're flying a drone unsafely, well, that's going to pretty much ruin their company. I mean, there's going to be that trust issue. So, again, I'm supporting what you're saying. I mean, it is a process, and it takes a little bit. And if we're just patient enough, but we can still progress in the technology and the capabilities. So when beyond visual line of sight is available, we'll have the technology to not only alert people what we're doing, where we are, but also promote the safety. So I really appreciate what you said. And that's number one. We talked about the airspace and why it's so important that majority of the drones are going to fly 400 and below. And I think Australia, I don't know, Australia's been really, really in the forefront of utilizing drones and the technology and regulating the airspace there. But what do you see in regards to the way you're seeing applications used now, maybe not necessarily in the US, what the US might adapt? If that makes sense?
Yeah. No, that's a good question, and every so often we get the sort of little bit paranoia that some other country is getting ahead of us, right? And I personally don't necessarily share the similar view that other countries are ahead. You see adoption of drones in Australia, Rwanda, New Zealand, even in the United States. It's all based on risks, by and large. You can sum it up in that. There are places where you can still do deliveries. I mean, you see that right now, Amazon and Google are also doing deliveries in the United States. Walmart is doing some deliveries. But they are doing based on what FIA's permissions that have been granted based on the risk-based approach. So I don't personally think you have to go to Australia or any other country necessarily. You may want to do that for your business reasons, but not necessarily for testing the system at large. What is interesting though is that our airspace system in the United States is far more complex in the sense we have a lot more general aviation, we have a lot more helicopter traffic, we have a lot more uh, other types of things that happen in the airspace, commercial space, as an example. You don't see that in other countries, right? So it's a little bit easier for us to go and test it in a country where there is no helicopters, there is very minimum general aviation um, kind of a traffic. So we have a unique, this is the reason why I think the safety becomes so critical in the United States because of the diversity and the mix of aircraft and performance characterization. And that's the exciting future is to how do we enable all these diverse applications from drones to commercial space, going to the airspace. How do you make sure that they're interoperable and they know each other's existence and such? So um, I think every country should definitely try this and push ahead. Uh, but I'm not so sure that there is going to be a significant advantage to any one country or other. Every country has its own unique characteristics and law of business cases and such. So it will have to be very much adaptable solution based on where they're operating, what the risks that they see. If you're doing agricultural inspection, or you're flying between Hawaii Islands, it's a totally different risk than flying in the New York City. So I think it's one thing to fly in a different country where there's nothing, and there's another thing to fly in New York City. It's a very, very, very different characterization. So I think we had to
So
look into
PK,
that
do
because
you
the GPS
see?
is not always reliable, the communications, lots of different things that come into the play when you characterize the operations and the risk, the weather.
Right. Do you see that the first beyond visual line of sight operations, and I'm seeing it already, is where we have hubs. It's kind of like an airport for drones where we have one place to another, and it's a designated route. And I see that being something that we adapt first before we kind of like the wild wild west, just fly wherever we want. Um, what do you see in the future?
I think that's already started to happen by
Yes.
exceptions through hubs, right? So that has already begun. Some companies are already flying beyond visual line of sight through proper exceptions that they received from FAA approvals, and they have technologies on place. Um, and that has value certainly, and that has growth. But if you want to do deliveries, you may start from one place, common place, from warehouse or whatever, but you're going to different locations to deliver. So I think at the end, the goal is to make sure that we have a scalable and sustainable system that you reach to different classes of airspace and different zip codes and such. So to me, that is fundamentally exciting, and that's where you have everlasting impact to the entire society. So absolutely, the hub system works, and that may be a good starting point. But I think in order for us to make sort of a lot of progress and make sure that the entire society benefits from this technology, and we need to have system that scales, allows you to to go to places where aviation has not reached before. And that's where we are focused on. How do we make that system work?
So those I see as definitely a challenge, but that we're progressing already. Like you said, we're already starting to see that with some of the companies. Tell us about the supply and demand and the challenges that we're going to have, well, that we have now and that we will have in the future.
Yeah, great question. So the supply chain, we were taken back by number of supply chain issues even before COVID. So we are not even talking about COVID. COVID, of course, supply chain became a household term. But even before that, um, I was studying supply chain. I teach also supply chain related courses at the business school. So I'm a student of this topic for life pretty much. And so it's an interesting aspect because as more and more globalization happened, the supply chains become more distributed and complex and global. And that caused some brittleness in the system and we lost resiliency. We went to make things very efficient and didn't pay attention to resiliency. Now we realized that well, resilience is important. If you just look at the prior aviation supply chain, there are cases where we didn't have good supply chain for drones in this country. We didn't really have a resilient supply chain. There are situations where one ball bearing company goes on strike or they have challenges and the general aviation gets delayed. There are situations where casing manufacturer, we only have one or very limited number of casing manufacturers that are supplying to all engine manufacturers. So they have a problem and then everything is delayed. We had problems where we were dependent on ink that gets into PCBs and PCWs, printed wire circuit boards and printed wire boards. And that ink was produced in Fukushima area in Japan. And when they had disaster, that got impacted. COVID, we saw many things got impacted, microelectronics and such. So we have seen these examples for a long time. And typically supply chain has been very reactive, so we identify a problem, we try to fix it. And there are several reasons for that. One is there is a lack of digitization, so you really don't understand what's going on in low tier systems. And the reason that's happened is because we have so many suppliers that the original equipment manufacturer says, well, let's create a tier system. And it's evolved through automobile experience for a long time that we only talk to tier one suppliers, tier one talks to two and two to three and so on and so forth. So instead of original equipment manufacturing coordinating all the suppliers, they basically only talk to next tier down typically. And as a result of that, the visibility into supply chain got diminished because you only know what is going to happen to the load next year down or up. And you can't really change your production targets or low tier supplies if you don't know what is going on there. So I think what is needed is a complete digital network that shows you the on a dashboard fashion what the situation is at the lower tier suppliers all the way to the lowest possible, all the way to the mining. So if I am a big aircraft manufacturer, I want to see what are the risks or challenges to my entire production, all the way to the low tier suppliers. So if they're going to be, they got hit with something else, whether it's COVID situation, earthquake, or whatever else, what is that going to do to my upstream chain? And you need to understand that rather quickly. And you need to have a resilient supply chain. In other words, you have to see whether am I too much dependent on places where there is a geopolitical risk or there is a natural disaster risk. And so we are building a modeling environment right now that allows us to visually see where every supplier is, as well as figure out or do we have enough supply capacity in the nation. So as a nation, so what we are looking at is saying if we want to build 10,000 electric vertical takeoff and landing vehicles, we want to build 6 million drones, we have to have 2,000 larger aircraft and 1,200 helicopters and so on and so forth. Do we have enough supply capacity as a nation to stay competitive? And we don't have a clear answer to that question. We have basically some hypotheses. In some areas we are very weak, some areas maybe we are okay, but we don't have a really good answer. And the reason this is important is, United States aerospace and defense is $908 billion industry, and $78 billion trade surplus comes from that. And out of that, about close to 400 or more billion comes from supply chain revenues. So suppliers contribute significantly. They employed 1.2 million people, suppliers. And if we want to have the drone industry to flourish and the advanced air mobility industry, including eVTOL, to flourish, we need to have stable, resilient supply chain, because that's where the reason I brought up those revenue numbers is, if we have opportunity to grow, of course, economy, but we also have opportunity to grow our workforce, jobs, and such. If we say we won't do that, if some other country or some other place takes advantage of that, then we are going to impact our trade surplus and the way we have been enjoying trade surplus in the aviation, aerospace, and defense. So I think it's really critical to start looking at the supply chain and as a nation, as and our allies, as to what is the best way to set up the supply chain for the new technologies that we are building, and are we going to be able to sustain ourselves? Otherwise, it becomes a national security risk, which we saw in the small drone industry. Small drone industry, we didn't really create enough supply chain, so other countries took some advantage of that. They were able to capture major market share when we could have done the same thing, but we didn't. We lost out on the manufacturing. Didn't think about supply chain as could be a bottleneck. So now we are recovering from that through policies and other means, and adding more production capacity and such. But I think my thesis is that every new type of aircraft we want to build, at some point we have to make sure that we have a supply chain to go with it that will allow you to scale. I see already examples where in the beginning stages, people say, well, where can I go get over molding parts? So there is a challenge of small and medium enterprises to connect with these new entrants, because the new entrants only want few parts there, so they can't go to large manufacturers and they say, I need 3 parts of this type, right? So there is an opportunity for small, medium businesses to be part of this ecosystem. So we're trying to help with that through a electronic exchange platform that we built that allows small, medium enterprises to join the emerging and take advantage of the emerging aerospace and defense industry, which is awesome, because if we can bring in more suppliers, more manufacturers in aerospace, that's really exciting. So that's in the early stage. But once you get to your certification, you want some resiliency. You want more than just one company that gives you motors or ball bearing, because you want to maintain that resiliency in the system and not depend on single point failure, so to speak. And then as you scale your operations, you want not only access to suppliers, resiliency, but you also want to make sure that you're able to scale. So you will maintain multiple suppliers to the extent that's possible while maintaining good relations. But you also need other systems, other digital system that can allow you to create resiliency very quickly, change suppliers if one supplier has a problem of some kind, and so on and so forth, because you want to maintain that scale. There's also a huge opportunity in maintenance, repair, and overhaul for these type of emerging industry, the drones and advanced air mobility. These operations are going to be very much local, and just like the car maintenance and car repair, we would need maintenance of these electric aircraft. And the reason I brought up the workforce issue is that we need to couple all these things together. We don't even have a curriculum for how to maintain an electric aircraft. So as new technologies and new opportunities emerge, we need to have this balanced growth of entire ecosystem so that we can make sure that we have support services that are also ready. And aviation is a different ballgame than just maintaining a car. You need to have part pedigree. You need to make sure that parts are aviation grade, so you don't use unauthorized parts, as well as the maintenance technicians. They know and they're trained and they are certified, for the aviation kind of maintenance systems. So great challenges, but really good opportunities. I would like to see this as more opportunities. People can look at this and say, oh, this is a business opportunity. There is a research opportunity. There is a students for job opportunities. So there is just tremendous opportunities are coming in here for those who are look at the entire ecosystem and look at what excites you, where the gaps are, and just say, hey, let me jump into this area.
So in regards to that, is it the government, NASA? Are they reaching out to leaders in this industry and saying this is going to be a need uh, in the future, and how can we give you the information? I mean, where are we getting the sources and the information so that we can educate our business opportunities? And then, like you said, I mean, at this point, I'm not aware of a school or a program that offers the education so that here we are just trying to understand the technology and where the technology is going. And what you're saying is we need to be on top of, as soon as that technology is established, we have to have that workforce to support, whether it be building them, whether it be training, whether there's just, and as soon as you get established there, things evolve and change, and we have to be flexible enough to work, and provide that support for this new technology. In regards to education and the workforce, what areas do you see that we lack the most of, and where we need to really focus as teachers and educators and institutions? Where do we need to focus? Because I'm sure
Yeah,
that there's a lot of applications that we're using now that can be applied with UAS.
yeah, great question. Um, and the workforce issue is just experienced by many, and that's because we have pretty good jobs right now available, which is really great for our economy, as well as the people who are entering into the workforce, Googles and Amazons and many others. Um, so how do we motivate? The question really comes down to how do we motivate students to think about aviation and aerospace? I'll just be very focused on that topic. And we think that starting at middle school level, boys and girls both, into exposing them to say, hey, here is the exciting things that we do. What are the opportunities in aerospace and defense? How do you actually go to space? What does it take to go to space? How do you become astronaut? What does it mean by aeronautical engineer? What do they do? Why is it so exciting? You get to create things that fly. Lots of ways of encouraging and motivating and getting students, thinking beyond what they have been exposed to is something that we need to start doing a lot more. Not that we don't do it, we all do it to some level, right? But we need to have more of that so that students in the early stage get exposure to the possible opportunities, and then so that will drive them to internships and exploring few things. Maybe they join little drone club here and there, and join uh, model aircraft kind of thing. So getting them, to basically see how this is very fulfilling and satisfying career would be first step in my view. So obviously at that young stage, they don't think about it as a career, but they think about it what excites them, right? So I think that's the way to start, and then we'll see what happens after that. Some of them will be really interested and excited about it. Um, and then others may want to follow a different path, may want to become doctors or nurses or whatever else. That's also equally fine. Society needs everybody, but we also need more aeronautical and space professionals. So that's sort of where I think we need to start giving them. The more exposure we give, the better it is. It can be, there is not enough, or there's never going to be enough exposure. So for this, because we had the students learn in a different way now, they interact in a different way. So we need to adapt to that and reach out to them, and mentor. I mean, I got significant advantage of mentorship in my 20s, and I think that's where we also need to put more emphasis on mentoring students and people. I have a very active internship activity that goes on every year, pretty much all semesters. I love to interact with students and get them excited and get them to think differently. So, in a non-threatening environment, so it's a really another area where we all can contribute, and we all need to do our little share of that. And that's when things start to change. But I think the more we talk in these kind of conferences, workshops, summits, webinars, we look at it typically from the inter-systems view. Businesses tend to focus on what is their mission, which is what right thing to do. But it is government job, in my view, and also academicians' job. Look at it from the broader perspective and figure out what the opportunities are and educate people, students particularly, as well as expose these kind of opportunities to community of interest. So
I think sometimes it can be intimidating for the youth. They think they have to be a nerd or, somebody that, just more of an engineer basis. And like you said, when we talk about being involved in this industry, I mean, we need somebody with imagination. And that's why I think STEM and STEAM is so important, because it's just not the engineers are going to be doing this. Like you said, there are going to be people that have to, design the software, or work on the airspace. Maybe they're the air traffic controllers or the technicians, or the logistics. I mean, there's so much, and I think when we start talking about how they can be involved, as opposed to, oh, you've got to be really smart, or unfortunately, a lot of the technical aspects is more attractive or less challenging for boys, and that's, again, it's just a mindset, changing that mindset where children start to see great examples, like in the PR, like in the news, like I had, the example of, finding a lost child. Well, maybe that would, set the fire for somebody to want to be a part of it, whether they want to be a fireman or they want to, control the drone to find the child, or deliveries, the medical deliveries, like they did in Florida with the COVID test, or sending out in rural areas the 911 calls, sending a drone first to evaluate what they see, the situation. Is it really an emergency? Who do we need to send out? Is it something when we need to send out an ambulance, or we need to send out the police? Again, the more we see this on the news and the more we talk about it, I think the more interest we'll get all demographics, not just a certain area or demographic. It'll be boys, girls. I think the opportunities, especially with drones, if they have some kind of disability, it's not limited to that. If they're in a wheelchair, they can actually fly a drone. So I think that's really important. So we're seeing that, like you said, when you started this presentation, you wanted to talk about just the capabilities and how we're going to use this transportation, because it is a new infrastructure. Just like I'm probably dating myself, but I remember when computers first came, and they were the huge computers that filled a whole room. And now here we are with a computer on our desk or on our phones. I see the same thing happening with this technology, the drone technology. We're going to make it more and more accessible, and people will see it more and more. And so our youth will see, the importance of it. So we're getting close to the presentation ending. Can you tell us a little bit, just kind of, hit some of the bullet points and some of the messages that you want to give?
Yeah, absolutely. So I'll summarize, aerospace and approvals and airworthiness. There's one category to make sure that we can scale these operations in a safe manner in there. And then second is making sure that we have resilient supply chain so we can manufacture them and different types. If you just look at the drones, the motors, the printed circuit boards, wings, and all of those things. But eVTOL is even more. It's a tremendous opportunity in the supply chain and making sure that it's resilient and scales and all that. And then there's great opportunity to come into the workforce and even including businesses, for maintenance and repair and overhaul of these vehicles, particularly advanced air mobility, the larger vehicles. And there's great opportunity for faculty members to do research on setting the performance characterization, the students to enter and try, and communities to basically get figure out how they can use these new means of aviation to transform the society. How do we provide better services in medical service or anything for that matter, inspection of bridges and things like that. So I'm really excited about the possibilities that aviation is going to bring to us. And as I say, my personal dream is aviation in every zip code, and I think that really changes the way people will interact with the aviation and get access to the services that are much more economical as well as environmentally friendly. If we get to more electrified small drones or medium or large size eVTOLs and advanced air mobility, we see that we can actually be really good for the sustainable future for environment and such. So lots of excitement is uh, is coming, and can't wait to see what 20, 30, 50-year kind of increments look like from where we are. So and
So
it's
PK,
great
as a
to be part
listener,
of that.
yeah, as a listener, can you give us a little bit of how do we get involved? How do we start? I mean, do we start with our schools and our communities, or do we reach out to like NASA? I know that NASA has a lot of initiatives that are going out to the community. How do we get involved? How do we
Yeah, that's
continue,
great
putting
question.
these examples up? Yes.
Great question. I think all of the above, so if you're a small business, write SBIR, small business innovative research proposals, or STTRs. If you are into teaching, contact NASA and other agencies. They are all have outreach programs, many outreach programs. Attend conferences, organize conferences. If you get excited about it, go talk to the faculty members in the schools. I think universities also can play a pretty good role by connecting and enticing students. So most of the large universities have aerospace and mechanical engineering departments. So I think the faculty members are exposed to some of these ideas. So they can also, you can go talk to them, have them give talks on a routine basis. If a community of interest is interested, organize events like this on every month, flying club members and whatnot. So that way, there's a momentum, there's a network, so this is really about network effect. Once you have a number of people, that excited people come in, all of a sudden you start to see an impact
You
in
know
the
what I'm
community,
seeing a lot
and then
of?
imagination grows, so collectively, I think imagination grows even further if we are interacting and collaborating with others. So really, just take full advantage of every opportunity in schools, colleges, government agencies like NASA, and reach out. When in doubt, just reach out to our folks, myself included. So
I
if
think the
there's
other
anything we can do,
question,
we'll do.
I think one of the other questions that, when we're talking about getting involved and reaching out and doing network, is there resources? In other words, I have a lot of teachers saying, hey, we don't have enough funds to support a drone program in our schools. Or if I want, I'm a small business owner and I want to, you know, fulfill those needs that are going to be coming in the future. Is there money in that area where, for a startup company, or is there money to start a program in your local schools? I mean, where would you find resources like that?
That's a good question. I don't know if I have a clear answer to that, but I would say ask everybody. I mean, of late, I've seen philanthropists also getting involved quite a bit. So there may be opportunities in that for particularly wildfire kind of area where people are really concerned about what wildfires are doing to our country and many states, and how do we actually build technologies and improve the response. And the firefighters do a tremendous job, but if we can give them better tools, more tools, how can we do that? So philanthropists are interested. The reason I brought up that example is philanthropists is also an entity that you local level or national level, they offer some support as well as government. I know we have outreach programs, and I don't know exactly how they fund those things, but I would just ask people. That's my long lesson in personal lesson is just that share your problem with other people and see what suggestions they have. And sometimes you get a response that says, I don't really know the answer, but go talk to this person. That person knows the answer. So, and then you get lucky. So the more you explore, you will find some place. But yeah, I think it's a great question. I don't know if there is a central repository where all the
Well, I know that there's small
aviation
business
related grants got.
associations.
But
There's small
AIAA,
business
I know
associations.
AIAA does. Yeah,
Right.
AIAA, American Institute of Aeronautics and Astronautics, they also have some student events and grants and such. So I would reach out to these associations as well as AIAA, NBAA, AIA,
Right. There are
as well as
government
government.
grants out there specifically that will support a company if they've got an idea. In other words, they start with the idea, they see that there is going to be a demand, that there are some grants out there. And again, even with education, I think more and more industries realizing that we as a country have to move forward with this new technology, and we have to have that workforce. And so I see that there's more grants available specifically on putting some of the drone programs in the schools and starting with 8, 9, 10-year-olds. So well, we're almost out of time, and it's interesting because Sharon Rossmark from Women in Drones is going to be interviewing Meg, and specifically, she works on research and development, and that's what we're talking about. What we're seeing now and what we're seeing in the future. So PK, thank you so much.
Thank
Will
you.
you make sure you share information on chat, how we can get a hold of you and ask more questions, or if, again, it's so important. We're going to be putting up the survey too. So if you see, or if you have more questions for PK, please reach out, and we're going to be going on till 12 o'clock today. So if you have any questions, PK, will you kind of watch the chat? There might be some questions in there that are still asking you specifics on your presentation. So thank you again so much. And Sharon Rossmark again from Women in Drones. I really appreciate your segment. Go ahead.
Great. Thanks, Maggie, for the introduction. And thanks again to PK. That was an awesome dialogue that he had, and his insightful perspectives is always great to hear. But moving on to our next section is I have the honor and privilege of interviewing Meg Anand. Is that correct, Meg? Did I say that?
You made that sound much nicer than it is. It's okay. Meg Anand.
Okay, Anand. Meg is the co-founder and CEO at Applied Aeronautics. Applied Aeronautics. In her role, she oversees all aspects of the company's organizational growth and development, as well as she oversees their manufacturing and distribution. With over 12 years experience in organization and project management, Meg is an accomplished and dynamic leader, as I think you want to all agree once you finish hearing her presentation. So Meg, to kick this off, why don't you please take a few minutes to further introduce yourself and then share a presentation, and then we'll get into a little Q&A. And for the audience members, feel free to drop any questions you have in the chat. Meg, I'll turn it over to you.
Thank you so much for that intro, Sharon. I'm very excited to be with you all today. I'm going to put some slides up just to sort of give you guys some visuals. before I get started, hang on 30 seconds, please bear with me. Okay. So can you guys see that?
They're perfect. Yes, thank you.
Perfect, Sharon. Okay, so thank you so much. So Sharon sort of gave you a general overview of, oh, I think they're sliding through. Nope, we're good. A general overview of who I am. Like she said, I'm Meg Anand. I'm the COO of Applied Aeronautics. And I'm going to be talking to you guys today about sort of two main points. The first one being, who Applied Aeronautics is and the work that we do in the commercial drone space. And I'm also going to be chatting with you guys about something that is really near and dear to me and what I believe to be sort of the key challenge facing the drone industry today, which is this idea of flying beyond visual line of sight. So we'll sort of have a crash course in what that looks like, regulations, we'll cover challenges, and we'll cover existing opportunities. So to kick off, who is Applied Aeronautics? So to sort of explain who Applied Aeronautics is, I think it's sort of interesting to understand why we are. And so we launched in 2014, we're a drone manufacturer, but our story actually starts back in 2011, 2010. I get those dates mixed up, but when our CEO and my co-founder was working in the oil and gas sector down in Houston, Texas. And at that time, he was responsible for overseeing assets spanning hundreds of miles. And this is 2011, so things looked very different than they do now. But at that time, he started to hear a lot about the sort of time and cost saving benefits of drones for commercial applications. So he set out to see if there was something, platform wise that might be well suited to an application like his. And what he was looking to do was survey assets, survey pipelines, deal with security and surveillance of some of these assets. So since I'm sitting here today talking to you guys, I assume you can gather that he came up short. Back in 2011, which is, we've seen things evolve over time, but back then, drones that were available sort of fell into these two main buckets. We had consumer geared platforms, and when I say consumer geared, I think of things like the DJIs, the 3DR Solos, the, you name it, these little quad type platforms. They fly for 30 minutes on average, small payload capacity. They're great, they're affordable, they're easy to buy, but they're fairly ill suited for industrial applications, particularly ones with large data collection requirements like his. On the flip side of that, at that time, we saw this sort of emergence of industrial and defense type platforms. Those were great. They offered the payload capacities he was looking for, came with fairly robust sensors, but they cost over $150,000, which was, a difficult pill to swallow back in 2011 when no one really understood what the ROI was going to be for industrial drone applications. So it became clear at that moment there was an immediate need for a system that sat somewhere in the middle. So, that was this kind of purpose-built commercial platform for long-range industrial applications like his. Fast forward a few years, Applied Aeronautics was born, and we spent about 2 years in R&D and testing, designing everything from our airfoils right down to how our manufacturing was actually done. We wanted to hit a few key metrics that were long range, large payload capacity, stability in high winds, and low cost. Essentially, we were really trying to sort of figure out how do we build a workhorse platform that can fulfill these sort of commercial needs without that high price tag that's going to be a barrier to entry to most people, given that it was to him. So we launched our flagship product, the Albatross, in 2015. It has a 4-hour flight time, 200-kilometer range, hot swappable payloads, sub $2,000 base price. Importantly, it's built here in the US, and that's something that I think is interesting given the conversation PK was just having with Maggie about supply chains. It was very important for us to ensure that we developed that sort of manufacturing in-house, right down to our airframe, so that we were reliant on no one else, but also, being vertically integrated for us was obviously advantageous, given that it gave us the ability to really control that end price. We operate in 3 primary markets, and I'm walking you through these 3 primary markets simply because they all have their sort of different challenges when it comes to beyond visual line of sight, and some of them we've had, more ability to see this work being done than others. So the first is military. Military is great for us. It's given us the ability to fly long distances, perform some more complex applications, and really sort of understand where are the advantages of our platform or drones in general, where are the challenges, given that we can fly beyond line of sight in this restricted airspace. So we're seeing the platform used for long range reconnaissance, search and rescue, tactical training, these types of things. On the industrial side, we work in security and surveillance, critical infrastructure inspection, sort of these types of core applications that really were the springboard and catalyst for actually starting the company in general. Then we do some work in research and development. And I always like to say this is where we have all the fun. We partner up with a lot of research institutions, a lot of schools, and we do a ton of work in beyond visual line of sight research, whether that's through the IPP program, the Assure program. We also do a lot of work testing avionics, hardware, all that kind of fun stuff. Like I said, we are primarily a manufacturer, so we focus on long-range, low-cost drones. We also do work in the R&D and integration space and consulting and training. So having given you guys sort of a general overview of who we are and what we do, I sort of, thought a great way to spend our time today might be to talk about one of the key business challenges that we face as a manufacturer of long-range drones, which is, how do our customers really benefit from a platform with a 4-hour flight time without the ability to fly beyond visual line of sight? So I'm going to walk you through what beyond visual line of sight is, what the current regulations are, and how can we have success given the current regulatory framework. So to understand beyond visual line of sight, I think it's first really important to understand what the current regulatory framework around the safe operations for drones in the US is. So at the moment, this really relies on the concept of see and avoid. So we'll just remember that, see and avoid. And this is the primary reason that the FAA wants us to rely on this idea of see and avoid, is to ensure we avoid any kind of mid-air collision between aircraft. So that's very easy to accomplish on the manned aviation side of things. And how that's done is typically, you've got a pilot in the cockpit, they look out the window, they scan the horizon. If they see an aircraft coming towards them, obviously they're spotting it, they'll perform some sort of maneuver to avoid it, thus reducing the risk of a mid-air collision. Obviously with a drone, there's no pilot in the cockpit there, you're on the ground. So you're not able to sort of look out there and say, okay, is someone coming at me? And if so, what am I going to do? Hence why there's this requirement for, as it currently stands, remote pilots to be able to perform commercial operations in the US. They must be able to do it within visual line of sight. So that's VLOS, as it's called. Beyond visual line of sight, on the flip side of that, simply refers to a drone operation conducted beyond the remote pilot's ability to see the aircraft. And that also means see it without the aid of anything other than glasses, contacts, these types of things. So why do we care about beyond visual line of sight? Well, our company specifically, we manufacture a long-range platform. It's obviously best suited for industrial applications over a large area. All of these types of applications we see our customers using their systems for today would obviously benefit from the ability to fly beyond visual line of sight. Why? Well, for a few reasons. Imagine that example I gave back in the beginning of our CEO, Ryan. He's doing commercial oil and gas inspections. Perhaps it's a pipeline inspection application. If he's got that requirement to fly within visual line of sight, you're going to see a lot of this deploying, landing, perhaps traveling by car to a different location. All of that takes time. When you're working, at an application such as this, time is money. It's a huge challenge. So, the ability to fly beyond line of sight without sort of landing, packing up your stuff and moving on to that next point really gives you the ability to collect more data faster, take that data back home, and make decisions based on that. So, huge amount of increased efficiency and reduced cost there. On the other side of that, you've got this idea of improved safety. So if you're flying beyond line of sight, in many cases, then you're preventing humans from being placed in dangerous situations. That's for two reasons. One, oil and gas inspections. Today, they can frequently be performed by manned aircraft, helicopters, these sorts of things, putting humans in fairly dangerous situations. If there are drones being used, perhaps you're putting that pilot closer in to where that hazard may be. So taking the human element out of it, increasing safety, it's of huge importance to us. It's of huge importance to our customers. Question on everyone's mind these days: can I fly my drone beyond line of sight? Yes, but not easily. So that is the big sort of challenge, and I think something that PK chatted a little bit about is sort of, how do we figure out how to do this at scale? But for now, I'm going to sort of walk you guys through what it looks like today. So bad news is, as it currently stands, no one is permitted to fly a drone in the US without a waiver from the FAA. And what that waiver is from complying with the requirement for visual line of sight. And that falls under, I believe it's part 107.31. Jot that down and you can sort of get a more comprehensive overview of what that looks like. But essentially what that means is you need to prove to the FAA that your drone operation can be conducted safely without endangering other aircraft, as well as people and property on the ground or in the air. Pretty straightforward. The challenge is these waivers are difficult to get. So I'll sort of walk you through what the FAA is looking for in a beyond line of sight waiver in a moment, but they're difficult to get. There's about a 95% rejection rate, but good news is more and more people and businesses are getting these waivers every day, and it's just going to become easier over time as we sort of gather the safety data and, like Maggie was saying, showcase, various applications that are very beneficial, whether it's search and rescue applications or, emergency management. I would think, or do think, that we're going to see sort of a more openness to this type of thing. So what is the FAA looking for in a BEAV loss waiver application? A lot of things, but there are sort of 7 or 8 main components that you'll want to focus on, and I'll quickly walk you through those. So the boxes that you'll really want to ensure you tick when filling out your waiver application. The first one, and I wrote these down so that I do not forget them, everyone, so bear with me, but you should be able to demonstrate to the FAA that you have a way to always know the position, altitude, attitude, and movement of your drone, and that your drone will remain in the area of intended operations without exceeding the performance capabilities of your C2 link. 2, you want to be sure that you can explain to the FAA how you're going to avoid other aircraft, as well as people and objects on the ground. So that's that idea of seeing and avoiding. What is your strategy there? You'll want to have some detailed information as far as how you're going to be sure you can see your drone at least 3 miles away. What that typically looks like is you'll be putting in some language there about increasing visibility. So, people will use things like lights. They'll talk about high vis paint, decals, stickers, these sorts of things. 4, you'll want to detail to the FAA how you will be alerted immediately if your drone is degraded or functioning incorrectly. Explain how all team members involved in the operation will have the relevant knowledge to operate the drone in this context. Give a general overview of how you will comply with weather conditions. Ensure you have a strong C2 link. This is mission critical. I would write that down, imprint it on your brain. Strong C2 link, it's critical. We'll talk a little bit about that later on. And finally, if you have visual observers, and importantly and interestingly, the vast majority of waivers we're seeing being approved today do include visual observers, whether that's one or a sort of series of daisy-chained visual observers. So if you're using those, you'll want to be able to account for any latency in communication between them and the pilot in command. So finally, you've got a general idea of sort of what that waiver would look like. Are there things that you can do to improve your likelihood of being approved? Yes. And I'll put those into 3 buckets of varying importance, but that would be, there's technologies you can use, educational strategies, and documentation. On the technology side of things, there are quite a few ways we can look at improving safety. One way that we approach this is by equipping our systems with onboard detect and avoid. We use a vision-based system, but there are a ton of options available today, from acoustic, EDSB, ACAS computers, a variety of different things. And the offerings are increasing daily. Education, I will drive home education until the day I die. It is the most important thing, particularly when it comes to safe operations in the drone space. So one thing that we always sort of talk about at our company is that no 2 pilots are the same, no 2 drones are the same, and no 2 operations are the same. You know, we get folks coming to us and they say, I'm a 107 drone pilot, and we'll say, okay, great. What platforms have you worked with? When they buy a system from us, if they've not worked in the fixed wing space before, we'll figure out how to craft a training program that really focuses on developing those critical skills to operate a fixed wing platform. That's just one sort of general example, but we always say when going for beyond line of sight waivers, ensure you've got platform specific training. We offer it. You know, I would suggest asking the manufacturer of your drone if they offer it. If they don't, there are a ton of great flight schools out there that may. So that's the second one. And lastly, documentation. So the more you have, the better when it comes to getting your waiver granted. So I would suggest preparing detailed documentation around things like system failures, standard operating procedures, risk mitigation strategies, pre and post flight checklists, and always be sure to include your manufacturer's operating manuals. That's key. So sort of armed with these various things that you can do to augment your application, as challenging as it would seem to fly beyond line of sight, it is possible, and you certainly can do it. And like I said, you know, if we can be of any help to you in that process, be sure to ask questions.
Well, great. Thanks, Meg. That was extremely informative. And I want to remind our audience that if they have any questions, to please drop them in the chat. And for those of you that can see Meg's slide, she does have her contact information as well as their web address up right now. So Meg, we do have one question. Of course, I have a few questions, but let's start with Maggie's
Yes,
question.
ma'am.
She wants to know, how is your company addressing the flight time and how to increase with the BV loss technology?
How are we addressing the flight time, our flight time?
Yes.
So our flight time, what I will say is this. So we have a fairly large flight time, long flight time. Obviously, you know, we're seeing the most success in these sort of research and development applications, long range applications. That is challenging here in the US at present. To address that from a business perspective, we focused a lot of our resources on the military space, and we focused a lot of our resources outside of the United States. There's a lot of openness to BV loss here in the US, but like PK was saying, the airspace is a lot more challenging here. So it's sort of, you know, we can hum and haw about things being slow, but they're slow for a reason. There's, you know, population density issues, and there's simply more air traffic. So in the US specifically, we focused our energy on working BV loss in these sort of sandbox environments, more controlled environments, working with our customers to receive waivers in, you know, areas where populations are not particularly dense, and then working in the military space to, you know, fly these beyond visual line of sight applications to collect that data as it pertains to risks, system failures, to really augment those safety cases moving forward.
Great. And so a follow-up question that Maggie's dropped in the chat is she's interested in knowing, she says, great slide on the nutshell outline and what points you need to know to share with the FAA to get approval. I agree. I thought that was an awesome slide. Next, oh, that was a comment, not a question. So
Thank you, Maggie.
yeah, Fletcher's asked a question. He says, does your company currently offer BVLOS training? If not, can you recommend a vendor or training program?
So we do. And for BVLOS, we have a few ways that we approach this. On the technology side of things, we work, like I said, with a company out of California, and they offer a vision-based detect and avoid system. That's sort of the hardware of choice on board our platform that we see as being mission critical when going after a BVLOS waiver. We do offer training on board that platform, and we do offer consulting services to actually assist with filling out that waiver. We do all of that here in Texas. Actually out in Bernie, Texas at a ranch. It's a beautiful space to fly if anyone wants to come out and check it out. So yes, we do. I'm specifically on our platform right now, though that is something we've talked about, you know, with the experience we have flying beyond line of sight or interfacing with these sort of beyond line of sight applications. Is there perhaps a space for us to, you know, provide training on various other platforms, given that admittedly a you know, large, you've got a 10-foot wingspan, fully composite. Our system is fairly robust. It's complex. It would not be my first choice as an entry-level platform. And I say that as a business owner, being wholly transparent, we always want our customers to succeed. But, you know, perhaps there's some sort of trainer platform that we could look at as well to get you guys started on.
Great. And Fletcher's asked a follow-up question. He wants to know, is there a collaboration with FAA safety?
Is there a collaboration with FAA safety? So we've worked with a variety of different FAA in a variety of different FAA programs in the past. In 2019, we were involved in the IPP program with Kansas DOT and Iris Automation. We received one of the first BVLOS waivers, actually without a requirement for visual observers or ground-based radar. That was very exciting. And we are working in the context of the FAA Assure program right now with a couple of different schools. And we'll have more to say on that in a little bit.
Oh, great. We'll keep our fingers crossed on that. And
I know I was hoping I was having something I could say publicly before this chat, because there's a couple of schools we're actually working with, okay. and there'll be some news coming out in the next little while. But those programs are really interesting because, like I said, we have this vision-based system that we use, but there are a few other things that we're placing on board to sort of test and see how those might help augment the safety case moving forward.
Okay, gotcha. This one's a little bit off topic, but is in the education arena. So Samantha's asking, if you want students to break into this industry, what would be their pathway? Counselors, volunteering, any ideas or thoughts that you may want to share?
A great question, Samantha. And I don't think there's one pathway. Sharon, you and I have talked about this. Mine has been entirely circuitous, and I won't bore anyone with that now, but what I would say is if opportunities fall into your lap, take them. There are a number of different ways you can get involved. Interestingly, my first sort of taste of drones or aircraft was a visit by happenstance to an AMA field. Someone got me flying a foam aircraft. I was not willing, to be perfectly honest with you, at the time, but I did, and I crashed it on my first go, and it was horrifying, but here we are. If you're still in school, I would say, you know, if there's clubs at your school, mentors that you may be able to talk to, ask questions. Many of the great companies out there, including ours, have internship opportunities. We love working with students. We also love chatting with students. We perhaps are too chatty, but, you know, contact us if you have questions, if you have ideas, things you want to mull over, you're interested in starting a business. Let us know. And Sharon and I will actually be talking about this a little bit in the next month or so, right? We have mentorship programs. Right. And I think Women in Drones is working on developing one at the moment. So stay tuned for that.
Absolutely. And that's, to your point, it is needed, and it's a huge opportunity. And I think we're in the right time for offering that type of interaction and development efforts, both at the student level as well as for adults, because, you know, the average age coming into the industry is 38, 39, leaning towards 40, which means people are in their second and maybe oftentimes their third career. And having a mentor, having a program that you can come into to provide that guidance would be, I think, extremely beneficial.
Yeah, and particularly across a variety of different sort of segments of the industry. I mean, I see a lot of work being done to sort of mentor people in the pilot space, but it would be great to, you know, if you're interested in being involved in the drone space from an operational perspective, if you know, drone manufacturing is interesting to you, whatever it may be, you know, I think the focus of the Women in Drones Mentorship Program will be sort of showcasing a variety of those different voices.
Absolutely. So I have a question. I like to go back
Yes,
to your product. And specifically, we talked early on about supply chain shortages. And I know you mentioned that your drones, your equipment is built here in the United States, but like most things, there are some implications for parts and pieces that are done internationally. How are you being impacted by supply chain shortages?
Well, my hair was not gray before 2021. So we are being impacted like everyone else. But what I will say is this, we are fortunate to be very nimble as a company. So early on, actually, we've been seeing supply chain issues well before COVID, simply given the way that the sort of manufacturing pipeline and especially domestically has been built out. So the way that we combat this challenge is by figuring out a variety of different vendors, but a variety of different options for each onboard component. So we're not reliant on a single autopilot. We're not reliant on a single GPS. We're not reliant on a single airspeed sensor, you name it. So we've sort of built out these various packages so that, you know, if something's gone offline, whether it be, you know, a manufacturer of a external mag in France, they've closed down for some reason. Great, well, we've got the US vendor at maybe $10 more, something like that. It's fine, we'll swap it temporarily and we'll keep moving. It's required a lot of, you know, dancing around, figuring it out, being flexible, whatever that may be, but we've done it, it's fine, it's temporary. Long-term solution, if there are things that we can manufacture in-house, we're doing that. So we used to purchase various components internationally. It's easy enough for us to do it here. So that's the long-term strategy.
Okay, that's, you know, but what you're being very candid and you're being very smart in your approach to this, because so many, as I think in the earlier conversation when we talked about competitors or other manufacturers, they're finding it hard to continue to access or provide product to the marketplace. Let's see.
Yeah.
Oh, I'm sorry, go ahead.
No, I was going to say, yeah, I mean, it is challenging. I think for us, you know, we'll say the chips are there, the components are there. The challenge that we're seeing is they are much more expensive than they used to be. So certain folks are saying, okay, well, I'm not going to pay market price. I'm going to wait till they're available to wholesale again. And we're just saying, you know what, if we're going to lose a little bit here and there on this now, we want to get the systems out the door. We want to keep moving. So we do. And I'm candid about that because why not?
Yeah, absolutely. Okay, so our time is winding down, but we do have a couple more questions in here. Let's take this one since we're on the manufacturing route. In regards to manufacturing, is software and firmware developed in-house?
Yes and no. It depends on what that would be. So our platform is built entirely on the PX4 flight stack, which is an open source software. There are various things that we do internally to sort of, you know, augment that existing framework for our platform, but we do rely heavily on that, and we are pretty open about that. I think, you know, being involved in that PX4 community is something that we've been doing from early on, and you know, I think open source is sort of the way to go. It's something that we see even on the military side of things, this ability to, you know, for the customer to be able to interface with the software, make changes. It's really the path forward. So no, I mean, we make minor tweaks here and there. We'll make tweaks if we're integrating new payloads. Yeah.
Oh, total sense. Makes total sense. Okay, so this may be our last question. Maggie has another question. She wants to know, what efforts is your company doing to recruit the interest of girls and women?
Ooh, well, whatever we can. So we've joined Women in Drones, which is very exciting. And with that, and like I said, Sharon and I will be talking about this again soon, but I would love to, and will be leading the charge to develop this mentorship program through Women in Drones.
Great. Yes. And let's see, I think that's all we have in there. So Maggie, unless you have another question, I don't see anything else in the chat. Meg, one last opportunity for any final comments you'd like to make.
No, I mean, thank you guys so much. There was a lot to say and a lot to get through. So if there was anything that was left out, my contact information, like I said, is up here. Please email me. I love to chat and would be happy to answer questions you have about, you know, flying beyond line of sight, fixed wing drones, getting into the industry, being a woman in the industry, whatever it is, let me know, and I'm happy to help.
Okay, well, thank you so much, Meg. I really appreciate your support in joining us today, and we will definitely be talking again soon. And with that, Maggie, I'll turn it over to you. Thank you.
Meg, thank you so much again. It was a really nice segue from what PK was saying, and to actually have a company here in the US that is experiencing exactly what PK is saying. So thank you so much. It really was wonderful. Now, you know, when you are making these announcements, is there any way of following you on like Instagram or anything like that? Or do we have to go into the website to see the new progress with your company?
Yeah, of course. We're on LinkedIn, Facebook, Instagram. Right. I will put those links in the chat as well so that you guys can get them more easily.
That would be awesome. Thank you again. And by the way, we did post this survey in the chat. If you guys will download that and fill that out, really would appreciate it. Really need your input. And you know, if we're not filling an area that you feel is pertinent and that you want to learn about, having these presenters, please let us know, because that's really important. And we're also in the survey are asking specific about what applications that are using now or what you'd like to see in the future. So as always, we end our workshop with Evan Morelli. Evan is like the guru when it comes to safety. And, you know, throughout this whole presentation today, you know, safety is the most important. And if you're operating a drone of any sort, any kind, this is really key to listen to what Evan has to say in regards to what to do to prepare and what responsibilities that you have when you are flying. So Evan, take it away. Thank you so much.
Thanks, Maggie. Let me go ahead and share my screen, my presentation, and start it up. So my name is Evan Morelli. I run Elm Aerial Services. And today we're going to kind of piggyback what was talked about earlier when it comes to getting authorizations and such. Some areas where you can increase the safety factor and have these proactive efforts to get better access to more complicated flights, you know, as we go to beyond visual line of sight, things of that nature that are going to be real life considerations that I've ran into working with Maggie and conducting flights in different parts of the country, as well as doing insurance adjustments for route after weather events. So these are things that you're going to see in the real world that are going to affect you and can cause issues when you are actually conducting a flight for a client, especially if they're in front of you, because I guarantee if they're in front of you, all these things will happen. So that's just how it works. So we're going to talk about on-site considerations. You know, it doesn't really matter whether you're in an urban environment or a rural environment. There will be different factors, but there will be some base level considerations that you're going to do and have a standardized set of ways to address your site. So the main thing is, and this can happen, again, if you're like on a farm doing an agricultural job, this won't be quite as big of a factor unless, you know, you're buying a big piece of equipment or a silo, or if there's a cell tower or something like that. But in an urban environment, you're like, that's 100% you're gonna have to deal with this. So, you know, RF interference is a major factor. You need to really understand your connection to your drone. You know, most drones that we have, they run off either Wi-Fi or Bluetooth. But what can happen is if you're around other RF emitting devices, i.e. police, service personnel, or even just somebody having their own ham radio that could be bleeding onto your channel, somebody doing what they're not supposed to, there's a number of factors. You need to be cognizant of that, as well as metal. Metal will cause interference. It can cause issues with your data feed. It can cause issues with lost connection, especially if you just kind of cusp around the corner, just slightly out of straight shot. That can cause a problem. So you want to be aware of underground rebar. This is something we ran into in Chicago, where we had underground rebar that was causing a lot of interference. So that's something to be very cognizant of. Examine your surroundings and try to find a nice flat space that's far away from metal. Because when you first turn on your drone and it calibrates its compass, if that doesn't go right, that will, if you're doing something precision, there's going to be no precision. If you're doing a flight that is going to have more interference through a certain part of like your flight profile, then it could possibly cause your disconnection or cause erratic behavior by your drone. So in your connection planning, you need to be aware, like I said, like with DJI products, if you have Bluetooth, that's 2.4 gigahertz, and that's going to give you double the range as Wi-Fi for the same power, but half the data versus 5.8 gigahertz, which is Wi-Fi. And typically that's what you're streaming your video down from. Those are FCC typically licensed channels, and you'll see them on your ground station or your drone as a licensed channel, have an FCC ID on the back, which means you're good to go. The manufacturer already took care of dealing with the FCC as far as being able to access those channels, because there's the airwaves as a whole that is apart from the airspace that we access. We're also accessing the airwaves of the United States through the FCC. So, but there are, if you're doing extended range flying, maybe in agriculture or something like that, or you need high data at a range, you may be using 900 megahertz, you may be using 1.3 gigahertz. There are various other frequency widths that you can deal with. Also, if you want to bump your power up, right, above 1 milliwatt, you're going to have a ham license for that. It's a really great skill and side certification you can do all online. It's through the FCC. Just Google in how to get your ham license, and there's a jillion guides. But you want to be cognizant of what your connection planning is, because you may want to up your power if you're, let's say, in an urban environment and you know that there's going to be a lot of metal and there's just nothing you can do about it. Having the ability to say, you know what, I'm just going to crank up my power a little bit so I can kind of blast through that interference and still get the results that I need. That's a tool in your toolbox that you can have. So antenna positioning as well, you want to make sure your antennas, depending upon the configuration of your ground station, it's best to have, with like DJI antennas, you'll have the two antennas that stick out. They need to be at 45 degrees from one another. And that causes the highest range of, it'll cause cross hatching, right? And so each antenna will have a dead zone associated with it. And most of the time when you're looking at third-party antennas, whether they're like cyclical polar antennas or linear antennas, they'll show the bubble, like a colored bubble in their data that'll show where the dead zone of the antenna is. And so you want to make sure that your drone is never right away from where the dead zone is, because you'll get loss of connection. So you want to make sure that typically as well, that the long side of your antenna is actually what is facing the drone, not the tip, because the tip tends to be the dead zone. So that's something to keep in mind. Understand how your antennas work, where their optimal range and optimal connection are, and make sure that your ground station is always pointed towards that, so you can reduce the effects of the interference that you'll have on your operation. So wind and weather conditions, you also have to be super cognizant of, especially here in Texas, it's super hot. Okay, I'm gonna talk about this here in a minute, but that's gonna affect your battery life significantly and turns your batteries into a greater hazard than they would be otherwise. But also, it's really windy out here all the time. So you got to be really aware of, when you have like off-the-shelf drones, what is the burst gust threshold that will cause your drone to become unstable based upon your payload as well. If you're using a heavy payload, is that compromise the amount of wind that it can sustain flight against, right? Because what will end up happening with these drones is once they get off kilter, especially if they're large drones, like if you have like $1 million LiDAR payload, right? When they get off kilter, they just drop like a rock. They have no airfoil to help them unless you're in a fixed wing. I'm referring to multi-rotors here. They'll drop like a rock. Once they've lost that downward gust, because they're basically just beating the air into submission, right? To push themselves up against gravity. And once they're like teeter-totters. So you want to be very careful and cognizant of what the wind profile looks like having a handheld wind gauge for your exact location is a very good way of ensuring like, hey, I understand that the weather said that, we got sustained winds of, 14 miles an hour or whatever here, but I happen to be in between these two buildings that's causing a wind tunnel effect, and it's 20 miles an hour here. And so maybe I can go to this other area and check and say, hey, well, this is a calmer area, a better area to launch from. So you want to check your weather conditions in advance, 24 to 48 hours. Now, I know in Texas, like it can snow in the morning and roast you in the afternoon, but you kind of do have to do your best. Some places when you're trying to get a lance approval require greater than 24-hour lance time. So getting that stuff done as soon, like as early as humanly possible, is a great idea because, there's what's it called? Temporary notices, NOTAMs on notice to all airmen that will, if somebody of importance comes in, if there's a game going on, if you're near a stadium and they put a temporary flight restriction, TFR, on that area, you need to be aware of that. So you have to have researched your location pretty extensively in the weeks leading up to that operation and maybe reschedule it if it's not going to fly that day. Allow for flexibility. Make sure that your client is aware that there are a ton of factors that can derail a flight on one particular day, including, with weather, including lighting. If you're doing some sort of videography, lighting can be a huge factor. Whether or not you can start flying after civil twilight. Now we're in the summer, civil twilight is way sooner in the morning versus in the winter, it's way later in the morning because it is set, and you can Google when your civil twilight is, and that determines whether or not you're night flying or not, right? Which is a waiver consideration, which is a safety factor consideration, which means you have to put different things on your drones to be able to fly. And that can be a 10, 30-minute difference of flight time, right? So those are things to keep in mind. Recommended equipment, backup batteries. You can't carry enough. I mean, like just a ton. And make sure you can charge them on site if that's possible. Toolkit, you want to be able to repair as much of the drone as you can and fix, broken props break. It happens. Sometimes even just from wind shear, they can snap. You want to be able to fix small, minor gyrations. There is a lot of vibrations in these drones. If things haven't been Loctited properly and you have a screw come off and now your gimbal's unbalanced, you want to be able to address that on site and not cancel your flight. You want to have a pilot in command to visual observer communication. I also recommend always using visual observer, and it turns out with the research that was done that that helps with your authorization access. So visual observers are fantastic because there's always going to be something from a different perspective that they can see better than what you can see, because you are going to be task loaded with conducting the flight, flying the drone. That task loading is going to inherently cause your brain to prioritize and dismiss information that your visual observer may not dismiss and may say, oh, we need to be aware of this. But you also need to have communication. Doesn't help if they're on one side of the parking lot and you're on the other side of the parking lot and you're just trying to yell at each other going, what did you say? I don't know. You want to have a walkie-talkie or an established cell phones and earbuds work great. That's a great way to do it. But you want to have that digital communication between you and your visual observer so that you can calmly and clearly, even in a noisy environment, communicate different aspects and kind of talk about like, hey, if I say this, this is what I mean. Sit down and have a plan of communication with your visual observer that they're not trying to say, no, you're left, no, your other left. Say like, if I'm saying left, I'm referring to your left every time, right? So to avoid that confusion, because that can lead to an incident. Safety equipment for personnel. Whenever when Maggie and I go out flying, we always wear reflective vests. We always wear polarized sunglasses. Those are two main things that in any environment, minimum, you should be wearing those. One, because it will allow you to, let's say you're operating in a parking lot, that makes people more aware of your presence. But a secondary factor is we are representatives of the drone industry. It's always a good idea to look as legitimate as humanly possible. And people that are doing something they're not supposed to, don't make themselves highly visible. Right? If you look like you're supposed to be there, if you look like a professional, if you look like you are not hiding anything, the likelihood of somebody coming over and asking you some aggressive questions is a lot less than it would be. And that's good representation of the industry, because we are simply professionals that are trying to conduct work at a place, just like any other type of profession. And we want to make sure that impression is solidified in people's mind. Landing pad and spacing cones, you always want to have a place, a defined place, and I'll talk about this with return to home in a minute, a defined place where you can launch, have your operation, and return to, that you know isn't going to have a car parked over it after you've been up in the air for 30 minutes. You know that people aren't going to be walking around. You can, you know that's low on interference. That's good for your compass calibration. That's going to be vitally important. Give yourself space. Give yourself feet of space, because deviation will happen, especially when you're low to the ground and that thrust vector coming down off the props, especially if you're like a larger drone and it's pushing down. The closer it gets to the ground, the less stable it is, because you're getting pushback off of the ground from your thrust vector, from your propellers, that is going to cause kickback and instability. So you may get some deviation, right? So you want to give yourself a good, nice broad range. When I'm in a parking lot, I think the best thing to do is start with at least 2 parking spaces for any drone, right? Even large drones, small drones. Give yourself, to kind of give you guys a context, 2 parking spaces side to side would be a pretty good start for a landing space. Give yourself plenty of room. Don't try to do it in like some corner. First aid kit, accidents happen. People get nicked by props. It's the only moving part of a drone. So you want to make sure you can deal with any kind of minor lacerations or bleeding on site while you seek greater medical aid. And then again, the handheld wind gauge is a really great data piece of information. So your pre-flight checklist, I'm actually going to put this in chat for you guys. Let's see, let me pull up.
Yeah, Evan, and Fletcher wants to know, do you have time to answer questions about battery maintenance during the week via phone?
Yes, I do.
Because there are a lot of considerations, and we always like the part when you're talking about battery maintenance, because depending on the battery you're using for your drone too will make a difference on how you treat it.
I'll get the link here in a second. My link disappeared, but before the end of this, I'll put the link in. But I put together a sheet. This is just a template that I use for myself. It has my logo on it. You can just pluck the information and put it on yours, but it's just stuff you should think of. And this is information you want to be able to tell the FAA and you want to have on you at all times, because it's the mandatory and it's the vital information for the actual drone operation that you're going to need, including authorization ID. Things like that are going to show people that may know what they're talking about, being like, hey, do you have access to this airspace? Okay, well, where's your waiver? Where's your authorization ID number? Okay, let me close this. All right, so I want to talk real quickly about battery maintenance. This is a huge safety factor, especially in Texas. It is hot. It will stay hot forever, till the end of the summer. But you got to understand with these batteries is they're lithium polymer batteries. They operate between 4.2 and 3.8 volts. Most of the time, so with store-bought batteries, they have a PCB, a printed copper board regulator on top of them, which means that they're subject to battery drain or vampiric leach off of the battery. So if you leave a DJI drone battery up on a shelf for 6 months, you're going to come back, you ain't got no battery anymore. Right. So, but if you have naked batteries or batteries that just are the lithium ion cake cells and just have leads soldered onto them, which a lot of DIY drones use, you're going to have to manage through a balancer each individual cells. And there's advantages and disadvantages. The advantages is you can analyze and determine the lifespan of the battery, which is much more difficult to do with off-the-shelf batteries. But the downside is you also have to put in the extra work to charge it, discharge it, and store it properly. So with any of these batteries, and what the PCB does for you is they manages the voltage of each individual cell, and there could be multiple cells to increase voltage or have them in parallel or series in order to get different characteristics of the battery between 4.2 volts and 3.8 volts. Okay. That means that if you drain your battery past 3.8 volt, lower than 3.8 volts, it's going to become unstable and it's not going to charge well. And there are tricks you can use with a balancer to get it to pop it back up, but it's not good for the battery, right? 4.2 volts as well is also the cap per cell, and you can overcharge them. But if you continue to do that, and like racing drone pilots, they overcharge to like 4.3, 4.4 volts, right? But also they have their drones blow up sometimes. It's just part of it. So you don't want to, you want to be sure that you're not exceeding that 4.2 volts per cell or letting your cells drop below 3.8 volts. Because as electronics work, unless you have the PCB regulator, they'll just continue to drop voltage. And that's what happens when you leave that parasitic drained battery up on the shelf for months, is it's going to take electricity to monitor that battery. So it's just picking away slowly, dropping that voltage lower and lower and lower and lower. And once it gets low enough, that battery's trashed. Those cells don't work anymore. So storage mode, that's what the PCB does for you, is it maintains the voltage and keeps it from having high amounts of electricity cause instability. That can be different with regular like cake batteries, because they're just full of energy, just ready to pop at any time. So storage mode is actually empty, 3.75 volts per cell or 3.8 volts per cell. And you want to balance all your cells down. Now the PCB will also monitor each individual cell. So if you have a 4S battery and you want to have all the cells within a certain margin of voltage of one another, if they get too out of sync, that can cause a lot of damage and cause instability, and you'll have Le Chartier's principle kick in, and electricity will move from one cell to the other, and it can cause a fire, right? Because that's what happens when these things get too much electricity, too much energy, is they combust, right? That's the main.
Speaking of that, what kind of storage bags? I know I've seen a lot of, especially with the batteries that you have to really watch. What kind of storage do you put them in? Because I think that's a great
point. So you can buy I have some right here. I can show you. Let me switch off of screen sharing. Let's see. Okay, can y'all see me? So these these are the battery bags you can use, and actually have some batteries in them. Okay. So these are really great. Sorry.
No, I think just bring it a little closer to the screen.
No, it's because it's white.
Yeah, it's
but so those are the battery cells. Now keep in mind, let me go back to screen sharing. The one thing you got to consider is that those are good. They keep what they really do for protection is they keep something like, if you've got some tools by your battery, from something puncturing the battery. And that's a huge important difference. But if that battery goes off, that bag is just going to slow things down by like 15 seconds. It's still going to melt and go up in flames. It's not a surefire fire protectant, right? It's good to charge your batteries in those bags, and you can buy them in all sorts of configurations on Amazon. I've got a larger one that I keep my large battery in as just a carrying case for it. But know that they're good to have, but don't rely on them as like, everything's fine now. The other thing I would say is, wherever you keep your batteries, which should be a cool inside dry place, go to Home Depot, get some sand, keep a bucket of sand next to wherever you store them, because if they combust, you need a place to put it, right? Buckets of sand work great, right? If you want to get one of those metal ones, like a metal trash can with a lid, you can do that too. But that's what you want to have, a known place that if something goes wrong, if you accidentally puncture it, right? That happens, because if you puncture those and meet those cells, it's going to pop and it's going to go. And it doesn't like explode like a bomb. It actually starts wherever there was the puncture, or wherever the puncture point happens, it starts to blow out like a blowtorch, right? So you'll be able to grab it if you want, but you'll be able to move it. It's not just going to explode, right? So just so you guys are aware, look up what happens to LiPo batteries when they get punctured, and you'll see it's like a butane torch out of wherever that puncture point is. So the last few things I want to say about batteries, because it is a hugely important topic, is that you want to religiously and meticulously manage when and how you use your batteries. Batteries are consumable. You will go through them over time. If you use them a lot, you want to know, how many times have I used this battery? Because battery memory exists. Every time you use your battery, that's a cycle. That's a charge and discharge. When you charge it up again, you're halfway through another cycle. Batteries only last, and some of them, depending upon the quality, how hard you use them, how much you discharge them, how much you charge them, because we'll talk about C rating within batteries, which is the how quickly you fill them up and how quickly you discharge them. That will cause things like elasticity. It causes a breakdown of the elasticity of the ability to take in energy and release energy within the battery, and you'll start to get performance, some meaningful performance differences, especially in heavy lifts. So you want to be able to walk or monitor, and every time I just take some gaffer's tape and a silver Sharpie on my batteries, and I just put a little dash every time I cycle it. And usually my batteries, it's like 60 cycles. And then what you'll see is when you start to do a punch out, which is like just a full throttle go, or when you start to do a heavy lift, you'll see your voltage take a big sag because it's trying to compensate for high amperage into your batteries or into your motors, your ESCs. And so that voltage will dip. You'll see that voltage sag, and it'll catch back up in time after a second, after the amps start going properly, because it's going to pull the amperage it needs, and it'll just drop the voltage. But you'll see that dip, and that's when you know that the battery is not performing adequately, and that can significantly affect the mission, because if you don't have a whole ton of batteries, and sometimes they are really expensive, and you're trying to do a precision flight that's like long distance, long range, you're going to get unpredictable behavior, and that can cause you to land, that can cause issues. And then you're going to need to return to home, which is another reason why you should have your landing system, your landing ground space, because that will you want to have your return to home set in case something like that were to occur.
Right. And I also know that having a log, not just marking it on the battery itself, but having a log on the activity and
definitely
how much you've used it really does help. So that's a very good point. Thank you.
I think I'm out of time.
We got about 4 minutes. So is there any, points that you want to make? Again, Evan makes these the charts and the information available for you. So if you want to follow Evan, he can share that information with you.
And here's one more thing as well. This will be the last point I make. Drones, by and large, are solid state systems. Even in VTOL drones, I mean, they'll have servos and actuators and stuff, but keep in mind that if you use your drone a lot and it goes through a lot of wear and tear, there are bearings in each motor, and you want to be cognizant of them, that occasionally you do need to change and service those bearings. A lot of them are sealed, so you just swap them out, and there's tools typically to do that. But if you hear grinding noises on your drone, because they can seize, and if they seize, you're in trouble, right? That's one thing and it doesn't happen often, and like racing drones, happens all the time. You got to replace it because they're crashing all the time.
Right.
But with regular like service drones, wind gusts can cause wear on the bearing. So if you're in a windy environment pretty regularly near wind turbines and stuff, be cognizant that is a moving piece of wear potential serviceable area in the drone. So that'd be my last thing, and just be cognizant. Here's my information right here, and so who was asking about speaking to me?
I think it was Fletcher. So Fletcher,
that number is good. That's a good number. You can just reach out to me on that phone number.
And text him, because he responds to texts
yes.
very often.
Yes.
Well, again, thank you so much. You always end this workshop with a lot of great information. I really appreciate it. And by the way, AUVSI Lone Star chapter is one of our sponsors. They're a great resource, for information. Drone Plus is a local company here that sponsors us. Half, Chariot, Women in Drones, of course. Fox Fury is another huge sponsor, along with Les Penn. So I wanted to thank our sponsors again for making this workshop possible. And please fill out the survey if you have something specifically you want us to address next month. We're still open to bringing forth our presenters. So please share with us what you'd like to see. And again, thank you again, PK, Meg, Sharon, of course, Evan. Thank you so much for joining us today, and basically, we are at the top of the hour. So again, thank you and bye-bye. Thanks again, you guys. Take care.
I went
and-
ahead and put that checklist in the chat for everybody if you need
Okay,
it.
wonderful, wonderful. And again, we recorded this, so if you want to look at it later on, feel free. Usually we have it uploaded on our website, northtexasuas.com, in about a week, and we'll have that available for you. And if you've missed any of the other workshops, you can always look at it later on. So again, thank you so much, and we'll see you next month. Bye-bye.